right, welcome everyone. Welcome to the fourth ForceNet webinar. My name is Chad Cook. I am going to give just a few announcements and then introduce our panelists today. I'll be very brief. As a reminder, this is being recorded, and I'll kindly ask you to keep on mute throughout the process. And our moderator, which I'll introduce in a minute, will actually give the specifics on how you can ask questions. A couple of updates with ForceNet. We do have a second funding cycle. And if you've already submitted through the first cycle in spring, you don't need to submit an LOI. Those who haven't would have to have submitted an LOI. It is due October 1st. The RFA is on the website. We're also planning a virtual symposium in March, which will consist of a number of speakers. Stay tuned for that. ForceNet is also sponsoring a special issue in JMMT. You've seen some of the studies that are coming out now, but the special issue will most likely be released in either January or February. And then our next webinar will be on December 6th with Vivek Subia, and information is forthcoming with respect to time. We did move the time up this go round just so our European colleagues can actually chime in. So if you're wondering why we started at 2. All right, now I'd like to introduce you to today's panelists, and we've got a good one. We have Dr. Julie Fritz, who's a distinguished professor in the Department of Physical Therapy and Athletic Training, and she's the Associate Dean for Research in the College of Health at the University of Utah. Her research has focused on clinical outcomes and underlying mechanisms of response to spinal manipulative therapy in persons with spinal pain. Her recent work has been funded through the NIH, DoD, and PCORI. We also have Dr. Beth Wickelstein, who is the Eduardo D. Glant President's Distinguished Professor of Bioengineering and Neurosurgery. She's a trained biomechanist whose lab has been continuously funded by NIH, NSF, industry, and foundations, and it's involved in the study of approaches to improve diagnostic and treatment approaches for joint pain. And Dr. Winkelstein is an MPI of SpineWorks, which is another U24, and she's a friend of ForceNet. We also have Dr. Vitaly Napadal, who is a co-I of ForceNet U24. He is a professor of physical medicine and rehabilitation, as well as radiology at Harvard Medical School. He's the director of the Schoen and Adams Discovery Center for Recovery for Clinical Pain at Spaulding Rehabilitation Hospital, and has been a pain neuroimaging researcher for more than 20 years. And lastly, we have Dr. Partak Khalsa, who is also known as Peter Heiston, who is a clinician scientist who retired in 2022 from the National Institutes of Health as the director of the Division of Extramural Activities in the National Center for Complementary and Integrated Health, NCCIH. The NIH, New York State Center, and Whitaker Foundation have funded his initial and original research. And as you all know, Dr. Khalsa is a legend in the force-based manipulations field. Our moderator for today is Dr. Greg Kalchuk. Dr. Kalchuk is the professor and, in fact, for the Faculty of Rehabilitation Medicine and Physical Therapy at the University of Alberta. Dr. Kalchuk is part of ForceNet and is also considered one of the most innovative mechanisms researchers in the world. Dr. Kalchuk, it's all yours.
I'm going to have to tell people I didn't write that intro, Chad, because we've got a lot of innovative people right here. Welcome, everyone, and thank you, Chad, and thank you to our presenters today. I'm sure all of you have been in some kind of conference where you really want to see what happens with this panel that's there, and then for some reason it goes over time, and we've got time for one question. We're going to turn that around today so that the majority of our time is spent on questions and the interaction between our panelists that we have here. So we're going to start off with 10 minutes with Peter, and then 5-minute presentations from Beth, Vitaly, and Julie, and then moderate the discussion that happens from there. So what we'll do for that part is accept questions through the chat only. We're going to stay off the microphones because that can be a little confusing. And then we'll take a look at that because there's probably things that might group together as themes or other things, and we'll try to get to as much of it as we can without any duplication. So with that, Peter, would you mind sharing your screen now for our first presentation, which will be on well, I'll let you tell what it is, Peter, but.
Well, let's see if I can get to it here. For some reason, my carefully orchestrated, here we go. All right.
There we go.
Okay, so everyone can see that? Yeah? Okay, good. So first of all, I want to thank the organizers of today's symposium and my panelists, and I'm really thrilled to be here. I'm really looking forward to hearing my colleagues' presentations and then the ensuing discussion amongst all. I've been charged with giving the history of the research on force-based manipulation and somehow doing it all in 10 minutes. So I'm going to go pretty quickly here and see if how close we can get to that. So my disclosures are here on the screen. I'm retired. I've got no finances, and I've got research. So there are three epochs really that I think is relevant to talk about in terms of force-based, the history of force-based research. There's what went on prior to the middle of the 20th century, so that's around 1950-ish. And most of what has been recorded are anecdotes and observations by various practitioners. And then starting the second phase is really in the latter half of the 20th century. So roughly the 1950s up to the end of the 20th century. And we see a lot of clinical studies of various types, but no phase 3 efficacy trials, as we would call them today. A lot of mechanistic studies that were really important, both for showing us sort of what some of the things that are going on with force-based manipulations, but also what's not. But arguably, they haven't really moved the needle of a change in how force-based manipulations are done, nor on whom they are done. And I include my own research on that. So this isn't, trying not to condemn others. I just don't think we've gotten that far yet. In 1975, there was a really critical workshop. I'm going to talk about that in a minute. And then at the very end of the 20th century, there was the US congressional authorization for the National Center for Complementary and Alternative Medicine and the funding that has brought to the field. And I'm going to talk about that for a minute as well. Over the last couple of decades, I think there are two things that really characterize the research that's happened. And it's the increase in rigor in the research. And this spans, I think, all areas from basic science to mechanistic to clinical trials. And the really other critical thing, I think, is the new technologies which have become available to the investigative community. And I know my colleagues are going to be talking a bit about this in their presentations, and I think in the discussion as well. And the importance of that in terms of developing new insights into mechanisms, and hopefully that will lead to new theories and models for moving the field forward. These are the data that I wanted to start this off with, which are really the number of journal articles indexed in PubMed under the rubric really of force-based manipulations. And of course, now that's not a term that's in PubMed, and it's a term that's sort of relatively recently been coined, I think arguably by NIH. And so if you have to break that term down into its components, and you can see at the very bottom of the slide here is the search criteria that I used to develop this. And what you see is that, of course, is that there are sort of small numbers of articles being published starting in the late 40s and 50s up to the 70s, and then it kind of starts to take off into the 1980s. And what I want to show you in this, to try to put all of this in context, is where are these sort of inflection points, that is, things that happened that contributed to the rise in the research. I mentioned previously this in 1975, there was a workshop at NIH on the research status of spinal manipulative therapy, and I'm going to talk about that in a minute. In 1978 was the start of the new journal called the Journal of Manipulative and Physiological Therapeutics, JMPT. And about 4 or 5 years later, it actually got indexed. And so all the articles that got published in JMPT start to show up here. And there are a number of other really important journals that are also focused on manual therapies. And I'm just using this as a placeholder for all these journals that have come into being since this time. Around the end of the 1980s, arguably 1990, there was the resolution of the American Medical Association boycott. Now, this was a decade-long effort by the chiropractic profession, which filed a lawsuit against the American Medical Association for essentially antitrust activities. That is, they were trying to boycott and constrain and really eliminate the chiropractic profession. And long story short was the courts eventually decided in the favor of the chiropractic profession, saying that the AMA had been involved in illegal activities of antitrust activities. And they required the AMA to change its messaging, which it did reluctantly, but it did. And the significance of this is that it enabled members of the AMA, that is medical physicians, to begin to collaborate and not risk being drummed out of the AMA, essentially. And I think that really contributed to a lot of the scientific interaction that has developed since then. In the early 1990s, you start to see the first systematic reviews and meta-analyses, in this case for spinal manipulation for low back pain. Again, the significance of this was that there were enough clinical trials that one could actually have systematic reviews and meta-analyses, regardless of the quality of the research that had been done before it. In 1998 was the congressional authorization for the National Center for Complementary and Alternative Medicine, now known as the National Center for Complementary and Integrative Health. And then fast forwarding into 2019 was the NIH-led workshop, it was an NIH workshop led by NCCIH on the neurocircuitry of force-based manipulations. And that, of course, was the workshop that directly led to the funding initiative and the funding of the three networks that I think through the U24 mechanism that everyone's familiar with at this point. Now, if you take all these out, these are all articles regardless of the type. If you constrain this search to just randomized controlled trials, you see this. And what you see again is that these RCTs, they started it really into the 1980s and upwards, and then sort of increased to where you see currently there's something on the order of 250 to 300 randomized clinical trials in the force-based manipulation field being done every year. And I've color-coded this to show this sort of brownish gray color is on the search term manual therapy. The green is on osteopathic manipulative therapy. The massage is massage, or the blue is massage, and this sort of orangish color is chiropractic. Now, for each of these years, these actually is more than 100% of actually all the RCTs, because in some cases, they were comparing, say, chiropractic to massage or osteopathic manipulative therapy to other forms of manual therapy. But you see the overall trend, which is a lot of clinical trials, but it's also interesting to see how these get indexed within PubMed. So in 1975, there was this workshop that was held by NIH. It was led by Murray Goldstein himself, a osteopathic physician. This was a congressionally mandated workshop. And I think arguably NIH did a pretty good job. They really did get the leading figures in the world of manual therapies together. They had people from the United States, from foreign countries. They had senior staff from NIH, specifically the Neurology Institute. They had medical physicians, chiropractors, osteopathic physicians, PhD scientists. And the result of all that over 3 days was a lot of testimony, some data, and resulted into this 350-page report. And after it was all over, the NIH staff got together, reviewed all the testimony and the data that had been presented, and then came up with a summary that is included in this large report. And I wanted to focus in on just one sentence that's in that summary, which I'll read to you. It basically essentially says, quote, specific conclusions cannot be derived from the scientific literature, either for or against the efficacy of spinal manipulation therapy or the pathophysiological foundations from which it's derived. And essentially what they're saying here is, from a neutral perspective, in 1975, there wasn't enough scientific literature to really make any decision about whether this was or wasn't effective and whether it was or wasn't safe, which were viewpoints that were espoused within that workshop. About 5 years later, a Canadian medical physician, Michael Livingston, published this article in the Canadian Family Physician Journal. And I love the title, The Mystery and History of the Spinal Manipulation. It really rolls off the tongue. I'm not going to go into much what he talked about here. He talked about the history, and the key fact that I think was pulled out of this was that there's documented history, and many other authors have reported this as well, going back over 2,000 years of the use of various forms of force-based manipulation pretty much throughout the world. He cited a few journal articles which were leading up to that really talked about these sort of anecdotals and observational studies. He commented on the NIH workshop, which had happened about 5 years previously, in which really also, and he concurred with the finding that it's just not enough scientific data available to confirm this. And even though his personal experience, because he utilized manipulation, was that this was beneficial. So here is the data on the NIH funding, and specifically NCCIH funding on force-based manipulation research grants. These are data that are publicly available via the NIH reporter. I pulled them out just last week, I guess. And the green bars represent the number of individual grants, and the blue line here is the funding in total dollars, both direct and indirect, that have occurred since the beginning. So you see about $5 million total from the beginning first year up to roughly about $30 million over the last couple of years. And there are all kinds of interesting reasons of why this curve is the way it is and why the funding has had dips and spikes. I won't go into that, but the key point is that there has been this steady increasing amount of funding over the last couple of decades for the field of force-based manipulation research. And I think it's the sum total of that over the last couple of decades is now on the order of about $350 million, which has been devoted to that. And I fully expect that this will probably continue for the foreseeable future. So what have we found from all of this over the last 50 years? There have been a lot of systematic reviews and meta-analyses, which are shown in this graph down here. I've cherry-picked 5 of the more recent ones, which were all for one intervention, one type of force-based manipulation, in this case, spinal manipulative therapy. And they all pretty much come up with the same finding, which was that it has clinically significant effects, but the effect sizes are modest. And this is the graphic that comes from the Rubinstein et al. Article, systematic review on British Medical Journal. And it shows on the bottom here in the graphic the clinical effect sizes for both pain and function. So we know we have something that appears to be effective, but the effect sizes are modest, but we've got this massive problem, and we really need to be getting something that has moderate to large effect sizes to really be addressing this condition. There have also been a number of mechanistic studies, and this is an article out of Bill Reed's laboratory at Alabama, where they had really looked at, in this scoping review, characterizing under different types of force-based manipulation and looking at what those studies had found were the responses to those force-based manipulations in animal models. I'm not going to go into the point is that we do know a fair amount of things that happen. And the challenge for us now as a profession or as a scientific discipline is to put together these new models that enable us to move this field forward. So this is a cartoon I stole off of the web that shows the history of the Earth going back 4.6 billion years ago, looking at through all of the geological eras and epochs, and going all the way up to the Holocene, where humans start to make their mark. And here we are driving our pickup trucks. And this is, if you'll use this as an analogy of what we know has been 2,000 years plus of use of force-based manipulations, we are here. We're just starting the research really endeavor on this. And I think we've come a long ways in roughly 50 years, and we have a long ways to go. So I'll stop there. And Craig, I think we're not taking questions and comments now, correct? We're going to go to the next.
That's right. We're going to wait till the end. So thanks very much, Peter, for that really, really nice overview. I'm sure each of us has experienced some slice of that timeline and can tell lots of stories about it. But now we'll hear from our first of the 5-minute speakers about their views of where things are going. And I'll just ask Beth Winkelstein, if you could please put your slides up on the screen now and take it away.
You can see my slides, I presume. Yes?
Yeah, looks good.
Okay. I flattened them into a PDF just to keep myself on the 5-minute time frame. But let me begin by thanking everybody for the opportunity to speak, particularly my colleagues at ForceNet. And I'll just sort of say, I think when we were putting this together, I was asked to talk about mechanism. When we had our pre-call, where Peter and myself and others got on, it occurred to me that one of the things in talking through what Peter was just going to show you was that actually part of the overlay to the mechanistic approach is the advent of the technologies and the evolution of the technologies, which has allowed us both an opportunity to become more rigorous, but also to understand and probe the various aspects along the mechanistic, very, very reduced schematic that I've shown you here, but really thinking about the local and peripheral responses, which have among them both in thinking about pain and thinking about force-based manipulations and their modulation of these mechanisms, structural and mechanical responses, neuromodulatory responses, inflammation and immune regulation, certainly electrophysiologic inputs, which go to, frankly, the central nervous system and its processing and its sensation and its measurement of the perception of pain. As we think about those mechanisms, I want to overlay what you've already heard from Peter about that 2019 workshop, where we really were focused on understanding, naming, and describing and thinking about those relevant mechanisms, but also the techniques that are used to probe those relationships. So I overlay a schematic that many of us have been working on to think about these relationships in defining mechanisms. Just pulling from my own lab's research, we think about multifactorial or multifaceted approaches to understanding spine pain, both from a diagnostic, but also from a treatment modality. And so we break it down into, which is where I'm going to go with my few slides today, mechanics, symptoms, and the system, physiologic sequelae in the whole body system, as well as mechanotransduction. If we look over time around the biomechanical mechanisms that feature or that feed into those mechanistic local to central responses, certainly the techniques that we use as a community have evolved along that same time frame. And in fact, I found it a little hard to go even further back than the early 2000s, where we've really been able to look at relationships between different tissue mechanics, afferents, and estimations of how we make those measurements as they relate to either simple spine mechanics or transduction of neural signals. But if we then look on the right side of this slide, certainly there's been an evolution both in time and space and scale of the kinds of questions that we can ask. So whereas some of us started making strain measurements as the end-all be-all of the local mechanical response, if you just took that particular planar measurement on a tissue surface, it did not enable or ignored the depth component. It also didn't allow the resolution that we now have with AFM and other kinds of printing approaches where we can look at cell mechanics, which I think is super important to think about. If we build off of that and think about the neurophysiological mechanisms, again, we can go through time in this way. And, I wanted to feature, as we were talking before others joined us on this call, some of the great work that Peter and his lab have established, really linking those mechanics with neural physiology. Again, I can't go too far back, but in the lab, we can get back at least 20 plus years. Others have measured the neural outcomes at different time points, but as we've evolved, and as we've evolved as a scientific community, we've been able to use optogenetics to look at brain circuits in pain. We could use that for treatment. We could use that for diagnostic. Folks have continued to evolve and add in gene therapy as a way to genetically modify and probe these circuits and mechanisms. So I think one of the things that's really important as we think about this, at least from my perspective as an engineer, is to continue to iterate with the advances in technology. Another area, and this is to set up the next speaker a little bit, is to think about the whole system. We have the ability not to look in isolation from either a tissue component, but we can take a whole bunch of imaging approaches to look at different tissue components, to look over time, to look at local as well as central processing. We can determine and distinguish those therapies that work. Here I'm showing you a drug intervention that had a different pain outcome, but certainly that could be useful as we think about FBM. And so I'll just end with a few provocative questions maybe to help us think about this as we have the discussion, thinking about the advantages is coming towards us and that sit with us right now with advantages in time, space, and systems, thinking about the evolution and the ability to develop new sensors and technology, really taking advantage of interventions both to study and to improve. Imaging is one of those, and I know we'll hear more about that. And also we've had a lot of discussion about how biomarkers can help us understand those mechanisms. And with that, certainly relating that back to the clinical scenario and not just at the bench or in the cage. And so I will cede the rest of my time to the next speaker, Greg.
Thank you, Beth. And that will be Vitaly Napadal. So Vitaly, if you would throw your slides up there. What a great contrast to see things starting off from just a few people getting together and deciding on terminology to looking at the latest in technology. Thank you, Beth. Okay, Vitaly, whenever you're ready, I'll start your time.
All right, great. Can you hear me okay? Can you see my slide?
Yeah, Vitaly, we're seeing your presenter view, though, if you just want to swap the screens.
How about now?
Yeah, good.
Excellent. Well, it's a real pleasure to be here, and I want to talk a little bit about how do we try to get at some of these outcomes and try to understand both brain responses and other responses in humans, and how we can do that. One way to do that, of course, is with neuroimaging. So I'm going to be talking a little bit about kind of the role of neuroimaging and trying to understand force-based manipulation. So there's many different kinds of imagings that are out there, and some have been applied to understand FBMs and some have not. But they all kind of emanate with the idea that neuronal activity can be assessed by multiple different types of processes that are downstream of that neuronal activity. Now, you can pick up neuronal activity directly through an electromagnetic response with techniques such as EEG or MEG, magnetoencephalography. There's also neurotransmitter responses and neuromodulators, such as endorphins, that could also be assessed in humans with techniques such as PET, positron emission tomography, and magnetic resonance spectroscopy. And then there's also a secondary response to neuronal activity that's based on the hemodynamics. So an increase in blood flow, an increase in blood volume, blood oxygenation, all happen when you have neuronal activity somewhere in the brain. And you can assess that with optical imaging techniques such as FNIRS and with functional MRI or fMRI, probably the most common technique that we've seen out there. So there's different ways when looking at techniques such as functional MRI to look at functional activity in response to force-based manipulations. And so we can look at directly the response to a force-based manipulation by using what's called task-based or stimulus-based fMRI. And so here you can have a multitude of different kinds of stimuli, either enacted in a singular fashion, almost like a delta function, where you have manipulation and looking at the time series of brain response that is happening after that. Or you can kind of try to group these things into tasks that are sort of repeated, or what's called a block design intervention. And this is also commonly done with functional MRI, and we can think of ways to do that. And I think it's important to think about how this might apply to force-based manipulation. So some of the limitations here is that most neuroimaging techniques are plagued by low signal-to-noise ratio and actually require many repetitions of whatever it is that you're trying to study. And that is not necessarily in line with how FBMs are practiced, at least for something like spinal manipulation, where typically you don't give repeated spinal manipulations to a patient many times over. And so this leads to some challenges in how to apply functional imaging tech to study these kinds of interventions. So, however, we could also look at other tasks or other challenges that are happening either at baseline or after a spinal manipulation, for example. So here we can, it's almost like a black box. We can take spinal manipulation or mobilization or anything else and have some sort of challenge or a task that's happening before and after that. And with proper controls, we can interpret any sort of changes that's happening from one state to the other as being due to the intervention that you're trying to study. And so these kinds of tasks can be cognitive challenges. For example, in this interesting paper, there was a series of videos that were playing, and the patient, a chronic low back pain patient, is told that, you know, you're going to be repeating these maneuvers afterwards. And so you can look kind of like the salience of this and the potentially even the movement-based fear that's associated with some of these maneuvers, and how that might differ between patients and healthy adults, and how that might differ after spinal manipulation. And so what this paper found is that there was, in fact, a decrease in brain response in low back pain patients after the manipulation in certain brain areas that are processing cognitive executive content. And that's different from mobile immobilization intervention. And that's also very different from what happens to healthy controls, which is a very important point, that chronic patients do respond differently than healthy adults to many different kinds of tasks and challenges. And so it's something to keep in mind when designing these studies. So there's also other ways that we can look at brain activity, both before and after, and this is with functional connectivity MRI. So this is a different form of functional MRI. And so here you just see the, in blue and in yellow, kind of the rise and fall of an fMRI signal over time. So this is over time, you see kind of a fluctuation of the state. And what neuroimagers have found is that these kinds of fluctuations are not chaotic and random, but actually segregate into distinct networks that we can then assess kind of the power of these networks before and after a force-based manipulation. And so this can be done with just a simple resting state, where the patient is lying in the scanner at rest and we're collecting data over time. And so you can look at, say, for example, spinal manipulation versus mobilization. You can cross this over. You can compare it to healthy controls. These are all typical types of designs. And what this particular study found was that there was a shift in the way the salience network is organized. This is a specific network in the brain. And the way this network is organized before and after a spinal manipulative therapy intervention has changed, and that's different from mobilization. And so the take-home message is that, first of all, we already do have some evidence that spinal manipulation influences brain activity differently than mobilization. This is important and needs to be followed up and verified. But also we should note that chronic pain patients demonstrate different brain responses than healthy adults. And so when designing these kinds of study, it's important to keep in mind who these interventions, these clinical interventions, are actually directed to, and that's for patients. And so we do need to, I think, enroll chronic patients, chronic back pain patients, for example, and not just repeat our studies in healthy adults. These patients typically suffer from central sensitization in the brain, have different interpretations of contextual factors. And so it's important in the future to keep that in mind, to embed neuroimaging outcomes into, say, longitudinal trials like RCTs. And so RCTs are very nicely designed where you can have a neuroimaging outcome that's embedded within the flow of an RCT. And so you can also explore the influence of various contextual factors. And just a quick plug to the Cook et al. Paper recently came out in Frontiers in Psychology, which was a ForceNet effort to try to understand the role and to define what are contextual factors in terms of force-based manipulations. So thank you very much for your attention. I'm really looking forward to discussing this.
Thanks so much, Vitaly. Yeah. All right, on to our final panelist of the day, Julie Fritz, who will be offering her perspective on where things are going as well. So anytime you're ready, Julie, looks like the screen's still firing up. There it is. Start anytime you like. Thanks.
Sure. Thanks, Greg. And I'm going to really pick up on where Vitaly left off nicely for me and have us think a little bit more about this topic of contextual effects and placebo and how these factors factor into understanding mechanisms of force-based manipulation. And thinking about this in a little bit, and about what we've learned about this along the way since the initial studies on placebo came into the literature. And really, if you trace this back, as most of you will know, the sort of initial paper that still gets cited probably thousands of times a year was published in 1955 by a person who was an anesthesiologist, reflecting on his experience in World War II of patients who he wasn't able to deliver morphine to, or at least this is the story, who still experienced pain relief when he gave them essentially a placebo. And, you know, I think this is, in looking at that original paper and then thinking about the way we've thought about this in people who research mechanisms related to force-based manipulation, as well as other areas of clinical medicine, what this phenomenon means is something that I think we're just now beginning to maybe peer into a little bit more, with a little bit more depth and nuance than has often been considered. So I copied this particular headline. This was from the New Yorker, and just in 2011, and really shows that idea of a placebo is something inert that does nothing, but yet can have this very powerful effect. And as I said, we've come a long way from perhaps thinking about placebo in this way. And I like particularly the framing from the paper that I reference here from 2002 about increasing recognition that this is anything but an inert phenomenon, and that really the framework given by Mormon and Jonas was to think about this phenomenon as the patient's attempt to make meaning out of what's happening to them in a therapeutic context. So we've learned of various things that really I think we have to bring into research related to mechanisms and force-based manipulation about this phenomenon and when analgesia is enhanced. We understand, and really placebo is rightly and primarily attributed to the impact of expectation and positive expectations of the patient, or negative, on the intervention and its outcomes. But we're starting to understand that it's even more nuanced than this, and that other aspects really have a powerful influence on the degree to which patients experience analgesia from interventions and their meaning. So, in particular, the social context, the extent to which the provider plays a role, is something that we increasingly recognize. And there's also been a good deal of research to understand the neurophysiologic mechanisms that underlie both placebo and nocebo. And one thing I think that in thinking about study designs and thinking about the research moving forward, that's particularly relevant to bear in mind is the difference in the neurophysiologic responses in what's usually labeled as the expectation phase, where patients are anticipating receiving an intervention that's either going to be pain relieving or pain generating. And then the response after having received that intervention, and these are different neurophysiologic phenomena and have different pathways. And there's several other key things that I think we've learned about placebo that should influence how we think about this in the context of force-based manipulation. So first off, and pictured here on the left, is that placebo responses are very individual to a person and very specific to the type of intervention that's being studied. So the particular diagram here was from a research study where they were looking at two different scenarios of how the doctor described an intervention to patients with experimentally generated pain. And one was much more just sort of fact-based. The scenario B was much more empathetic. And really what they were showing is that there's certain individuals who are responders to greater or lesser extents, and there are individuals who are non-responders to placebo under both of these scenarios. And then the other as Vitaly brought up in his talk, the other really key consideration here in thinking about the research moving forward is to understand that the way we have typically thought about a placebo response and a treatment response is this very additive model where there's a response that's attributable to the placebo. And the difference between that and the real treatment, whatever that is the treatment effect. And that under this additive model, if the placebo response becomes larger, you would expect the treatment effect to stay the same and the overall effect in the treated arm to get bigger. But this really, this model's really been at least suggested to not really be what plays out in terms of the placebo response being equal for both active treatments and placebo interventions. So if we think about what that means, and this is a diagram that's talking about drug studies, but conceptually thinking about this in terms of force-based manipulation, that an additive model doesn't allow for an interaction between the placebo and the drug-specific effects. So if we think about this and we think about that overall treatment effect would be underestimated if all we attribute to the effect of the active treatment is that response that's above and beyond the placebo, and not recognizing that there's a potential that the specific effects of the intervention and the contextual effects interact in a way that makes the actual effect of the treatment perhaps larger than we measure when we do a typical placebo-controlled trial. And I think this is particularly relevant to consider in terms of force-based manipulation, because we've also learned a fair bit about the types of factors of placebos that make them more powerful. And in particular, this occurs when interventions are physical instead of pharmaceutical, which certainly includes various types of force-based manipulation. When the intervention is perceived as more expensive, which may not be the case always here, but also branded in a way that makes it attractive to patients, and also provided by enthusiastic practitioners who really provide a positive framing and expectation for patients about their intervention. And taken collectively, these would suggest that studies that examine force-based manipulation relative to placebo, as we know, tend to find relatively modest effects that we can directly attribute to the force-based manipulation under study, particularly when done in the way that we usually do this kind of research. So in thinking about, how might we look moving forward in terms of research design, I think, there's a few interesting things that people have done with this, particularly, again, mostly in pharmaceutical research, but may have a role in thinking about how to move forward with research designs in force-based manipulation. Beyond understanding and really beginning to assess contextual effects, there's also ways that we may think about trying to minimize the placebo effect when that's a desire through something like what's pictured here on the right, where this individualized response to placebo is taken into account, which may allow for a better understanding of response to the actual active intervention. And I will go ahead and stop there, and I think we can move on to our discussion.
Thanks, Julie. And as we're just waiting for some of your questions to appear in the chat, we've got one here from Chad, but I'm going to do something just that you normally don't get a chance to do as panelists, and just take a moment, realizing that the clock is ticking. We have 15 minutes here on our schedule. Do you have any questions for each other? You don't even have to put them in the chat. If you want to ask them directly, presenters, if there's any burning issues, things that you'd like to ask each other on the panel, let's give you a moment there, but otherwise we'll jump into some of the things that are popping up in the chat room now. Okay, if there are no questions, then coming from our panelists.
You've got a couple there, Greg.
Greg, they're raising their hands.
Yeah, I just wanted to give you as panelists, Beth, Julie, Vitaly, a chance to ask each other a question if you wanted to just jump in right now.
So, Vitaly, why don't you go first?
I go first. Okay. I was, I was really struck by how do we get sort of some of these really interesting peripheral markers that, Beth was talking about, intertwined with some of the, central sort of imaging markers that we're able to collect in humans. And is there anything specific that you think we could and should, if possible, to incorporate it with all the limitations of MRI or the limitations of EEG or other techniques? What would be the kind of the peripheral outcomes that you think would be feasible but still really important to track in humans?
Is that for me?
That's for, yeah, Beth, sorry. That's
because I was going to say one of the things that I was going to, if I was going to ask my question was, I guess my provocative question, I'm going to build off yours, Vitaly, because I will say I have two pieces to that. One, which is I've spent a long time, and I know many others, and I've looked at some of the folks on here who have used the animal models as a way to, while not a perfect sort of one-to-one analog to the human, does at least help it offers the platform to do both the brain and central measures, as well as ongoing and continuous peripheral measures, and to figure out that kind of platform, that kind of conversion factor, if you will. So part of what I would directly answer is to say, I think we have, and I'll take one of the questions in the chat, I think we have an opportunity as a community to use that space, both to exploit the technology, to define the mechanisms, but also to understand the proxies or the markers that we have, whether that's using the brain imaging as a biomarker, or whether that's using a blood draw, or whether that's using a tissue response. Now, I say that also acknowledging that there is no good conversion in space, time, or scale between an animal, whatever size it may be, and a human, and that still becomes one of those challenges we have. But then I'll turn it back on you, since I have the mic, and say, but if we're thinking about FBM and we're thinking about the outcome for a patient, in my view, as a non-clinician, the two biggest outcomes are function and pain relief, right? I mean, those are sort of what we're going for. At least from the pain relief side of this, in some ways, doesn't it all just matter what's happening in the brain? So that's my question for you.
I mean, certainly from a perception point of view, if you're looking at pain intensity, that's the case. But as you alluded to, that in the pain research field, that's actually started to take a back seat in terms of clinical trials and outcomes to pain interference. And so now it's thought that it's not really pain intensity that is most important and should be tracked as a primary outcome. It's actually interference. Like, how much is the pain actually interfering in your life and affecting you from being able to do what you want to be doing, activities of daily living. So I think if we're looking at this from the standpoint not of pain intensity, but of pain interference, then embedding imaging into these kinds of longitudinal clinical trials where we can really move pain interference would be something that we can get, maybe not mechanism, but mechanistic like outcomes.
Okay, I'm going to just jump over quickly, Peter, and quickly, Julie.
Yeah, actually, I have a question primarily directed towards Julie, though, if there's time, the other panelists. So there's been a lot of discussion, particularly over the last, say, 15 years, and I think really led by the physical therapy profession, where there have been numerous articles that I've read that essentially comment with the idea that the specificity and the manipulation or mobilization probably is not important. The biomechanics don't really appear to be changing, at least that we can measure in any significant fashion. And this leads to what you were presenting about, that these contextual factors, the ability to augment essentially, whether you call it placebo or non-contextual or whatever, there are ways to improve patient sort of outcomes, like we were just talking about, in terms of pain and interference, and as well as other ways of measuring it. So the question I want to be a little bit provocative about this is, I ended my presentation with this recognition that we're only getting modest effect sizes. We need to be getting moderate to large effect sizes to really treat this really massive problem. So how do we get there, and what should we be focusing on?
Well, that's an easy one. Yeah, I mean, I think this is why I thought, this topic had to come into our discussion. And I was actually going to ask a version of the same question back to Vitaly in terms of, even if we are thinking about pain interference, like this provocative question that Beth asked of, isn't it all really just in the brain? And we're trying to figure out how to prime that in some way that's going to have the largest impact. I guess, I don't know the answer to your question. I'm interested in what others say, but I do think that perhaps this need to disentangle what we've labeled as placebo, what we now talk about as contextual effects, to try to disentangle that from some kind of quote unquote real treatment effect is maybe fraught and sort of destined to keep us spinning our wheels in terms, and not thinking about these as the total effect of providing these types of treatments to patients, and that the whole meaning it has for patients, we can't separate it into components, and we have to think of it a whole and then think of it as a way to maximize it. I don't think that's a very good answer to your question, but I am interested in what others have to say about that.
Well, I might jump in, Julie, and let people marinate in that for a second and see what they come up with. And maybe just paraphrase a few things that are in the chat box here. And that if we sort of have this ascendancy of biology and brain, when we've maybe traditionally been thinking neuro and biomechanics, and now our horizon, we really are bio now. Do we have the methodologies clinically to really incorporate these in a meaningful way? Because reductionist wise, we've said, let's just bring in this treatment and isolate it and see what the effect is. How do we design more modern studies, or do we have the tools yet? We're not talking technological tools. Do we have the methodological tools to really bring these components into our clinical studies?
Well,
Experts feel free
I'll say
to jump in.
something provocative if I could, which is you've basically said so if we eliminate the technology of it, I guess my question, and I've said this, I don't know if our colleagues from NIH are on here, but some of my ForceNet PIs have heard me say repeatedly, this will require that we have sample sizes and statistical models which are robust enough to handle all of the various different things that are being called out in the chat, the different dosing, which takes on so many different kind of forms when we talk about it this way, the history, the confounding factors that are physiologic, as well as those which are called contextual. So I would just throw out, I'd love to know if people think we have the statistical and sort of power to do such an endeavor.
Yeah, I think that's a great point, Beth. And I know I can say for sure within NIH, that's always talked about whenever there's a proposal coming in for a given type of trial. And, it's bang for the buck, is really the essential question. But I think that's always the case for any grant, that it's up to the investigators to make the case that why this is going to be impactful. And I come back to Greg's point. I think this is really important, because I'll keep coming back to this, that how do we make these interventions go from modest to at least moderate effect sizes routinely, right? And I think that's the question, I think that's before the field is, I've only seen like one or two trials or even systematic reviews where that is found that they're getting moderate effect sizes for using some sort of force-based manipulation for some sort of musculoskeletal condition. It's just not common to see it. So, but that's what's needed. So how do we get there? I mean, what is it? Do we just sort of say, okay, well, let's just really bang away on these contextual factors, and maybe it's not just that we're trying to do that, but we're trying to really, again, as priming the central nervous system and particularly the brain, so that it's going to, maximize its response rather than just shuffling people in and shuffling them out kind of thing as quickly as we can. Is there something in biomechanics or peripheral neurophysiology that sort of says, yeah, we got to really be, amping up X, whatever X is, kind of thing? Julie, any thoughts?
Well, I'd add to that. I do think that the NIH is doing some strategic things to advance that. So, best point about the necessary sample size to begin to personalize or understand personalized responses to various treatments across a host of physiologic or biologic or other kinds of measurements, and really being able to phenotype patients. It requires so much intensity of data that it takes really a collaboratory of sites working with common methodologies and sharing data to get there, and with computational sophistication to figure out what to do with that much information. And I think that the expectation that any one research group could do that on their own is probably not really very realistic. So I think, although there's a lot of issues that still need to be worked out about how we do work together and sharing more information and standardizing methods, that really feels like the way we get to the amount of information that's required to do what you're envisioning, and understanding what how to predict individual responses to specific treatments.
Great. I'll just remind everyone here that if you can pop your questions into the chat box, we won't be taking any live questions from the audience today. We'll just have the mics from the participants. But Vitaly, you wanted to chat in there.
Yeah, I want to jump in here for a second and respond to Peter's question also about the the small versus moderate, large effect sizes. A lot of that, I think, also has to do with the control intervention that we're considering here. Like there's a really great case study in terms of acupuncture, which is also arguably a force-based manipulation, where if there's been a lot of clinical trials of acupuncture, and typically if you look at trials that have compared quote unquote real to quote unquote sham acupuncture, the effect size, while significant, the effect size is very small. If you look at trials comparing acupuncture to usual care or some other type of intervention like that, the effect sizes are moderate. And so now we're getting to your moderate effect sizes. So the question is those trials that do show moderate effect sizes with, say, spinal manipulation, what was the control there? And then I think what we have to do as a group is to think about what exactly is the intervention that we're talking about, be it massage or spinal manipulation. And typically, if we're throwing away these contextual factors as something that's not relevant or not important to the intervention, maybe that's not something we should be doing. And because this goes into how we design our controls for these studies, right? If the relationship and the bond and the therapeutic alliance between the masseuse and the patient, between the chiropractor and the patient, is actually part of the intervention itself, that takes us into a different place as to how we design the control. So while we tend to think of this act of spinal manipulation that we're doing as being the most important part of the intervention, that may or may not be the case.
Yeah, I totally agree with you, Vitaly. I think, and that's partly where I guess my hopefully provocative question was about, how do we get there to these larger effect sizes? But it's also this idea of, well, I think the professions of chiropractic, osteopathic, manual medicine, massage, and physical therapy have really been trained as professions to think of this really the biomechanics. That's where it all started from. We're all saying, oh, well, it really matters where you adjust or where you mobilize, all these kinds of things. And I think that's one of the limiting factors at this point, is that there's a lot of studies that suggest it doesn't. And so then this question of what you were just talking about, Vitaly, about the interaction effects between the provider and the patient start to become more ascendant. And particularly when we're looking at non-pharmacological processes where it's intrinsically complex. I think this is the question then of how do you design such a study, and this question of, well, what control should be used, or is it no control at this point, right? And I think this, Vitaly, at NCCH, at least for a while, there was a time where NCCH says, no, we don't want, sham-based acupuncture anymore. We already think we know what's going on enough. Let's just do these sort of more pragmatic trials to see, what can you do if you're really, giving it all you got, kind of thing.
Well, unbelievably, we are at our time limit, and we'll maybe just stay on for a second or two, but we did make the promise that we'd be wrapping it up. So I just want to give our panelists a chance to just say something in conclusion very briefly. I'm going to give you 30 seconds, and I'm going to be brutal with interrupting you on this. And then we'll throw it over to Bill Reed, who's going to conclude us for the day and tell you about some things coming up in ForceNet. So let's go in reverse order and allow Peter to have the final word. So Julia, if you have a final thought for 20, 30 seconds.
Yeah, I'm going to echo what Peter was just saying. I think to get beyond modest effects, we're going to have to think in different paradigms and be innovative in how we design studies to try to really understand the clinical phenomenon of people receiving these treatments.
Sorry, that was me, Vitaly. Your thoughts?
I mean, my only thoughts, and one thing that's striking about this panel is just how important it is to get different perspectives, and having real multimodal, multifaceted researchers involved, and people coming from the clinical trials work, coming from the basic science, the biomechanical engineering world, and coming from the neuroimaging world, people kind of coming together and working together on designing some of these studies and asking questions that any one of us alone, I think, would have a difficult time asking and answering in our own lives.
So
It's like we should have
I'll just say ditto, because that's exactly what I wanted to say. But since I have 20 more seconds, I will say, if you're interested, please join SpineWorks.
Oh, it's like, yeah, you're advertising in the wrong shop there, Beth. No, the right
No,
shop.
we're partners. I am an active member of ForceNet, and we are
know.
trying to do things together. So,
and we are going to do things together, and I think you're going to see some exciting things in that direction coming up. So, from Peter, would you tie it all up for us? I'm going to give you 21 seconds.
Oh, thank you. So I'll just make a plug that I think that this kind of interactions that we're having today, as well as all the other interactions that the three networks are having, I think is exactly what NIH had hoped for these U24 grants, because I think it was the assessment not only of the workshop that was held in 2019, but NIH's own internal assessment, looking at all the data as to what do we need to move this field forward. And I think that's the question that's before us. And I think that the answer that seemed obvious to NIH was that we need to have real interdisciplinary work going on amongst people from very different perspectives, and bring them together and keep them working together to try to figure out, all right, where are we, how do we move the needle forward? The one thing I'll just make an argument for is that I still think that we need these ideas of looking at these mechanistic studies. In some cases, it's to eliminate things that probably are not important in terms of what makes force-based manipulations at least minimally effective. It may also be the case that there's something there that really does tend, on average, to be really important in terms of getting effect sizes up. And so I think that's where these networks, I think, can really shine in terms of what they do for the field.
Yeah, and I'm sorry. Thank you, Peter. And I'm sorry we didn't get a chance to answer everyone's question directly. I hope we touched on everyone's question a little, but this is only the old adage, leave them wanting more, because we're going to have more of this coming up in the future. And Bill, I just ask you to thank everyone and wrap us up for the day now.
we would like, on behalf of ForceNet, to thank everybody, all our expert panelists, our attendees. We've had excellent attendees on our webinars at ForceNet. We appreciate that. We do want to remind the viewers that it is on YouTube. It will be posted on YouTube, the recording of this session. Our next webinar will be on November 28th. And it will be on advances in RCT design. We will send out, through Twitter and X and various means. We encourage you to join that and give us feedback. There's several more ideas. If you have suggestions, you can email me or Chad. Just go to the website for future webinars and benefit. And we're going to have as Chad mentioned also, in March, upcoming symposium, and we invite everybody to attend. Keep your eyes posted for that. But again, we thank everybody for taking their time out, preparing the slides. The content was excellent. Ideas, the chat comments were good, and then we appreciate everybody's taking their time out of their day to attend. Greg, I'll turn it back to you.
Oh, thanks, everyone. And again, thanks to the speakers. We look forward to seeing you at the next ForceNet activity, and all the best. Hope to see and speak and collaborate with you soon. If the organizers could just stay on the link here for a bit.